similar triangles, and we know that similar triangles have three properties. The first one is they have all the same amount of sides, right? The second one was that all the angles are exactly equal, right? Third thing is, if we have similar triangles or similar polygons and we're missing a side, even if we have all the sides, we can set up a ratio of corresponding sides and then solve for x, right? This is what we did yesterday. Is this sounding familiar? Okay, awesome. So let's go ahead and notice it says solve for x and write a similarity statement. So I'm going to write the similarity statement first. So we can tell which angles go with which angles because you can see there's a green angle, a red angle, and a blank angle in each triangle. So I'm going to randomly choose triangle CAB. That part doesn't matter. The next part though, oh, I'm going to do a similar. Sorry, we're writing a similarity statement. So is similar to triangle, which angle goes with C? D. D, very good. They are both green. Then to F. F is to A, both red. And then E. Very good. Questions on that part? All right, so now because they're similar, we can set up a ratio of corresponding sides. Now, if you set up the incorrect ratio and solve for x, you'll get it wrong. So let's look at it. Look at our similarity statement. I'm going to even color coordinate it for you. AB. AB is to what side? FE. FE. So we know that this is to FE. So those are corresponding sides. So I'm going to set up a ratio. Do you want to go from big to small or small to big?
Small to big.
Small to big. So we're going to do 3 over x plus 8, because those are the corresponding sides, will be equal to, let's see, if we're going small to big, let's start here. DF, what goes with DF?
CA.
CA, so DF and CA. So we know we're going to have 2 over x plus 3. All right, so then from here, now that we've set up a correct ratio of corresponding sides, we can cross multiply and solve for x. So once again, pay attention carefully. I'm going to cross multiply. Let's get rid of this x plus 8 first. I'm technically multiplying this side by x plus 8. What's going to happen though if I do? It will divide out. Very good. So I'm multiplying both sides by x plus 8. Do I need to put x plus 8 in parentheses?
Yes.
Yes. All right, now I'm going to multiply both sides by x plus 3. Both sides, but what happens over here? Divides out. Very good. Then I'm going to erase this so I have room. All right, let's go ahead. Now we have to distribute, combine like terms, and multiply. So let's go ahead and do 3 times x.
3x.
3 x's. 3 times positive 3. Plus 9 is equal to 2 times x. 2x. 2 times 8.
16.
Plus 16. Now from here, once again, guys, please, 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 I'm begging you, don't just say I can float 2x and 3x is 5x. Do you know how many I'm seeing do that on the test and even on the retest? You can't just say that's 5x. It's not. You can't just float them together. To get from one side of the equation to the other, you have to use an operation. This is positive 2x. So what should I do? Subtract 2x from both sides. 3x minus 2x is 1x, or just x. So we have x plus 9 is equal to, check, that does add up to be 0, so we did it right, 16. Then from here, we're getting x alone. Minus 9. So x is equal to
7.
X is equal to 7. Very good. Any questions? Awesome job. Okay, go ahead and pass those in. Hopefully that was a good recall from yesterday. And let's learn the new stuff. So title your notes 2-4. Today we're going to be doing similar triangles. Today we're doing 2-4 similar triangles. We did do similar triangles yesterday. We're just going to build on it even more today. We're going to learn something new. Okay? So just remember, similar triangles will have the same number of sides. We learned this yesterday. They're going to have congruent angles, meaning equal angles, and we can set up the ratio of corresponding sides. That's not new. That's not the new part quite yet. We're going to get more in depth with similar triangles in a minute. All right. So once again, this is not new. We're going to review this so that it can help us with what we're learning today. So it says, state if the triangles in each pair are similar. If so, state how you know they are similar. Then complete a similarity statement. Okay, so does everybody remember 2 lessons ago when we were learning about angle, side, side, angle, side, 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 and which one did I miss? Angle, side, angle. Yeah, good. That's what we're going to use here today. So let's look at this. Let's look at this one. This is a little bit more rigorous than the problems we've seen in the past. How can we see if these are similar? So first of all, the first thing I see is vertical angles. Does everybody see the vertical angles? Okay, now look at the order the information's given. We still don't know if they're similar. We're going to have to check more things. We weren't told they were similar. We're seeing if they're similar. So look at the information. The only thing we have is a side, then an angle, then a side. Okay. All right, so side, angle, side. If they are similar, it's going to be by side, angle, side. But I'm not saying that they're similar quite yet. I've got to check. Because look at our sides. Are they equal? Can we just check by looking then? Not necessarily. But we can check to see if the ratios are correct. If the ratios are set up proportionately, they are similar. So let's go ahead and say, okay, so 12 over 6 better be equal to, we have to stay consistent, so since 12 was on this triangle, we have to stay consistent, 4 over 2. Let's see if that's true. Is that the same thing? What's 12 divided by 6? 2. 2 is equal to 4 divided by 2. 2. So we checked our ratios. I have to see that you checked the ratios. The ratios were the same. And we have by side, angle, side, they're the same. So side, angle, side. But we did have to check the ratios on this one. Now, if the sides would have been the same, we could have just checked like that first day. Does that make sense of how we're putting it all together? Kind of. Okay. So yes, by side, angle, side. And then our ratios were the same, so it's still side, angle, side. All right, so our similarity statement. Triangle, I'm going to just call it ABC. The triangle ABC is similar to triangle A was between side 4. Everybody look carefully. You have to get this right. A was between side 4 and blank. Now, what went with 4? What corresponded to 4? 2. So find 2 and blank. What angle goes with A? B. And then B was between 12 and blank. 12 was to 6. So we got to find 6 and blank. 6 and blank. So what goes with B?
E.
E. So therefore, C must go with C. All right. Any questions on that? And we're done. Okay. Let's do another one. All right. So it says, state if the triangles in each pair are similar. If so, state how you know they are similar. Then complete a similarity statement. So there's a couple different ways to do this one. Couple different ways. Now notice we're given all 3 sides. So I'm going to try side, side, side. That's quick, fast, and in a hurry. So I'm going to say if it is, it'll be by side, side, side. But you can't just say that without checking. Okay? Now notice, you got to set up the proportions correctly. Well, look at the sides here. Does each triangle have a smallest side?
Yeah.
4 is smallest and 6 is smallest. Does every triangle have a medium side? 6 and 9. And then the largest side is 8 and 12. So won't the smallest side correspond to the smallest side? Medium side correspond to the medium side. Large correspond to the large. So let's set up a ratio of corresponding sides. So I'm going to start over here. I'm going to go small to big. Why not? Or do you want to go big to small? It's really up to you. Small to big. Okay, let's start with small to big. I'm going to go with 4. 4 over, well, 4 is the smallest side. What's the smallest side over here?
6.
4 over 6 is equal to, I'm going to go with 6 over, 6 is the medium side. What's the medium side? 9 better be equal to, the largest side is 8. We're going from here to here, so over 12. Now do that on your calculator. 4 divided by 6. What do you get? Everybody should do it. What is it? 0.66. Okay? 6 divided by 9. 0.66. And 8 divided by 12. You're sure you checked them all? Okay, awesome. Are those the same? Yes. So by side, 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 these are similar. So then writing a similarity statement. Triangle, I'm just going to randomly call it ABC, is similar to triangle A. Careful. This one's where most people's similarity statements go wrong. So A was between 4 and 8. So the smallest side and the largest side, yeah? So find the smallest side, 6, and the largest side, 12. So A is to D, right? Yeah. Now B is between the medium side, 6, and the smallest side, 4. So between the medium side is 9, and the smallest side is 6, so that must be E. Thus, C is the C. Questions on that one? Okay, we're almost there. Say if the triangles are in each pair are similar. If so, state how you know they are similar, then complete the similarity statement. With this one, which angle relationship will we use? Side, side, side. And then we'll check the ratio of the corresponding sides, right? And how will we know which side corresponds with which side? I won't do it if you can tell me. Smallest to smallest, largest to largest, so medium with medium. Very good. I will go through this one then. All right, last two. These ones are quick, and then I'm going to just let you work. State if the triangles in each pair are similar. If so, state how you know they are similar, then complete a similarity statement. Think on this one on your own. This one's tricky. Okay, try this one. I'm gonna let you ask your neighbor what they think. Just think about this one. Are these triangles similar? If so, how do you know? If not, why not? Okay, go. Just tell your neighbor what you think. I'm gonna draw that in. You said we have some vertical angles. Okay. Okay. Anyone else want to elaborate on yes? Okay, good. Good explanation. That was a good one. Okay, who wants to go to court for no? Someone has to go to court. Come on. All right. All right, guys, so everybody look up here. This one was very tricky. That's why I had to go to court. This one would be no, because if they were similar, we know for sure all angles will be exactly equal. So you're right, Sean Bean. These are beautiful vertical angles. So we do have one angle that's the same, right? Is everybody following? Do we have a second angle that's the same? No, right? We don't. This one's red and green. Red and blue, and this one's green. So even if this one was red, would they be similar? No, because not all three angles of the triangle were the same, and they would be if they were similar. So both good answers, and this one the answer is not similar. So not similar. Okay, so what about this one? What about this one then? Are they similar? You say yes. You're right. Because we have vertical angles, and those must be equal. Then we have one other angle in common, purple and purple. So think about it. If we took 180, subtracted red, subtracted purple, took 180, subtracted red, subtracted purple, and we got green, wouldn't this have to be green? Awesome. So we know, yes, by angle, because then the third angle has to be the same, right? It must be the same if two angles are the same. So there's not really angle. But these ones are similar, because all three angles of a triangle are the same. Does that make sense? So I would like to call it angle. Because then if you think about it, it's really side, 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 because sides correspond to the angles, right? So, yeah. Awesome. Do problems 1, 2, 3, 6, and 7. Go. We learned this 2 days ago. Okay, if we have two triangles and we have two lines that are parallel, does that mean that they're equal? No. But we do know that if we have two parallel lines and a transversal, it's going to create alternate interior angles, right?
Right.
Okay. And we also have two parallel lines in this transversal. So right here, I'm also going to have alternate interior angles. Then do we have vertical angles that are the same?
Yes.
So which theorem would we use? Angle, 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 thus side, side, side. Yeah. Okay, here we go. I'd be taking notes again. All right, so now we're going to learn about the triangle proportionality theorem. This is new to us. So the triangle proportionality theorem. So it says, now if you want, you could just take a picture of this, because if it's going to take you too long to write it down, it might be easier for you to just snap a picture with your phone. That's fine with me. And you can have your phone out, okay? All right. So triangle proportionality theorem says, if a line parallel to one side of a triangle intersects the other two sides of the triangle, then the line separates the two sides proportionally and we have two similar triangles. So I'm going to read that again. So if a line parallel to another side of the triangle intersects the other two sides of the triangle, so it's intersecting this side of the triangle and this side of the triangle, then the line, this line, separates the triangle proportionately. And we have two similar triangles. So it's going to separate this side to this side proportionately with this side to this side. Now, that's only if those two lines are parallel, can you assume that? Does that make sense? Only if those two lines are parallel can you assume that it's cutting those in proportionally. Now, the two similar triangles formed here is this little triangle right here and this large triangle right here. So those are our two similar triangles. Okay, so this is just what this says, but in more of a symbol-y way. So it says AC, so side AC, so look up here, side AC is parallel to side DE. Does everybody understand that part of it? Okay, so therefore, AD, so AD is over DB will be equal to, CE over EB. There's a couple different ways you can solve using this triangle theorem. Now, what triangle proportionality theorem we'll use here is side angle side. Because does everybody see how in the small triangle it shares angle B? The angle B is still angle B in the large triangle. Does everybody see that? Look at the small triangle. Angle B is right there. Does everybody see the small triangle and angle B? Look at the large triangle. Does angle B stay the same? So they share an angle in common. And also we know the sides are proportionate because this side will be proportionate to this side and this side will be proportionate to this side. Now this is a different way of setting up a proportion too. There's two different ways of setting up a proportion with this one. So now we'll practice this. Really this one comes with just practice. Here we go. Okay, so it says, state if the triangles in each pair are similar. If so, state how you know they are similar, then complete a similarity statement. So there's a couple different ways we can do this one. I'm going to do this one a certain way, and then you might see me do it a different way in another one, and I'll clarify why. So first of all, keep in mind, guys, that we have this small triangle right here. We have triangle DBE. So DBE. And we also have triangle, I'm not going to call them similar yet until I've checked. So we also have triangle ABC, this big one. Now we know that if we have similar triangles, we can set up the ratio of corresponding sides. So let's do this one correctly and carefully. We don't know these two lines are parallel. We don't know, I know, I kind of have an issue there for a minute. So we don't know that these two lines are parallel. So we can't do this the easy way. We can't do this the easy way. We can't just do this over this is equal to this over this. If these two lines we knew were parallel, we could. But we have to check this the long way. So looking at this side right here on the small triangle, we have 5.5. Is everybody following me?
Yes.
5.5 is to this entire side now. This entire side. So what is 5.5 plus 2? 7.5. So 5.5 over 7.5. Does everybody see how those are corresponding sides? Is equal to, now I'm doing the small one again, so 8.25 over, and I'm going to do the full length now, so 8.25 plus 3. Good, 11.25. So check on your calculator. Are these ratios the same?
Yes.
What'd you get here? Well, how do you know then? You have to work. You got to do the math. Do it. Tell me, what is 5.5 divided by 7.5? 0.73? What's 8.25 divided by 11.25? 0.73. So 0.73 is equal to 0.73. So yes, they are similar. So now I can click this. Similar. They are similar, and we have to know by what. Now this one is side, angle, side. Side, angle, side. Questions on that one? Okay. Do problems 4, 5, 8. Now you have to fix number 8 because notice on number 8 there's a missing like side right here, but it should be 89.
So like if you want to do x 33 plus 89.
Right.
So, okay.
Yeah, so just write an 89 in there because it's just missing the typo. There was a typo, and notice how it's floating down at the bottom on accident. All right, so do those. Okay, everybody look up here. Let's apply that knowledge more advanced. So now notice, remember back to this. Okay, remember back to this. We were told if we have these two parallel lines, then these are similar triangles. Now when we got to these problems, we weren't told that they were parallel, so we couldn't assume they were similar. We had to check our ratios. But if we were given that the lines are parallel, we can know they're similar for sure. Does that make sense? Okay, because the triangle proportionality theorem says so. So let's do this first problem. Here we go. It says solve for x. So we're going to use all our knowledge to find missing links. Okay, so now notice it says these two lines are parallel. So we know they're similar. So we can set up a ratio of corresponding sides. Now because we were told these are parallel, we can actually set this up like this. We can say 11 over 8. 11 over 8 is equal to x over 9. The triangle proportionality theorem says if they're parallel, we can set it up like that. Because it's also going to cut the sides of our triangle proportionately. You could do it that way, or you could do it the long way. You could do 11 over 19. Do I need to show you the long way, or does everybody make sense of this? Okay, then we'll just stop. All right, so then how do we solve for x? Cross multiply. Multiply both sides by 9, but what happens over here? Divides out. Is x all by itself?
Yes.
Yes. So we have x is equal to, now you'll do 9 times 11, which is, so 99 divided by 8. So x is equal to
12.4.
12.37? 5. Okay. So if we were going to round to the nearest, let's say, let me look.
1,000.
Let me decide. Remember, I have a math degree, so I'm just kidding. I just know that's your favorite saying. I'm gonna have you guys, if it's like a huge long decimal, round to 2 decimal places, but if we're only here, just write the whole decimal. Does that make sense? That's only 3 decimals. That's the exact answer. So let's write. All right, questions on how I set that up? Okay, let's do another one. Stay with me. Solve for x. A little bit trickier. Now I sat and debated, should I do it this way or this way? How should I teach it? I don't want to confuse them. I don't know. So it's really, it's still debatable, to be honest, okay? So this is how I taught it last year, but I don't know. There's 2 different ways to teach it. All right, so first of all, we know this entire length is 9. We know that this piece right here is 7. We know this piece right here is 10. We know the entire length is x. So we can set this up because these lines are parallel. We know we have similar triangles. We can set this up a couple different ways. So honestly, the easiest way is just to go like this. We have this small triangle, which is similar to the large triangle. So let's set up the ratio of corresponding sides. So we'll do 10 over what? 10 over x, right? Corresponding sides. Does everybody understand that? If you don't understand why I did 10 over x, really quick, I'll clarify. So everybody look. We have to use corresponding sides if we're doing similar triangles. So this side corresponds to the large side on our large triangle. So we'll have 10 over x is equal to, and then we're going to do this side 7 over 9. Very good. Now that's the easiest way to do this one. Cross multiply and solve for x. Now watch, because there's a lot of you struggling with this, especially you back table, watch this. We're going to multiply both sides by, let's get rid of our 9. Multiply both sides by 9, but it divides out over here. Now we have to multiply both sides by what? X. Multiply both sides by x, but it's going to divide out over here. Right?
Right.
Okay. So now we have 9 times 10 is 90. which is equal to 7 times x, which is 7x. Now, how do we get x alone? Divide by 7. So what do we get?
12.85714.
Okay, so is this a long decimal?
Yep.
12.857. That's it?
No, it's 857,142.
Okay, so we'll round there then. All right, 12.875. Any questions? 8. Same thing. Just kidding. I have a math degree. I can say what I want. Just kidding. I'm just kidding. Okay, any questions on that one? For real? One more. More than one more. Here we go. Stay with me so I can let you work. Only a couple more. Don't. If I just set you free to work, you won't be prepared. Do you want that or to watch? Well, you can't have your cake and eat it too. All right, solve for x. Solve for x. So looking at this, guys, we've got to set up. Now, looking here, we don't have the parallel line thing with cutting another line on a triangle. So we're going to have to just set up the corresponding ratios and solve for x from there. So looking at this, guys, it's kind of hard because I noticed in one of the problems they didn't give you the angles. If they did, you could know for sure which side corresponds with which side. So notice I just went off of my best judgment. So like this kind of looks like 90 degrees, and so does this. So I just kind of assumed that those are the same. I think on a test and stuff, they'll give you the angles so that you can know for sure which ones correspond. Okay, so let's set up the ratio of corresponding sides. So I'm going to say 2x minus 1 over, well, notice that was across from my green dot. So what's across from my green dot over here? 12. So 2x minus 1 over 12 is equal to, I was on this triangle, I got to stay consistent, so 3 over 5. Then we'll cross multiply and solve for x. I'm going to multiply both sides by 5, but it divides out over here. I'm going to multiply both sides by 12, but it's going to divide out over here. Now, do I need to put 2x minus 1 in parentheses?
Yes.
Absolutely. It's 5 times all that stuff. So now I've got to distribute it through. 5 times 2x is 10x. 5 times negative 1, which is equal to 3 times 12. 36. Piece by piece, solve for x. Add 5 to both sides. So we have 10x is equal to, right? Divide both sides by 10. So x is equal to 4.1. This is the last example that I'm going to let you work the rest of the time. Okay? Here we go. This one's trickier. It is trickier. So you need to look. Very much trickier. Solve for x. So we have this. Now I'm going to tell you that these lines are parallel. So these two lines are parallel. So now we know we can set it up as this over this is equal to this over this. Well, that's that piece, right? We need that piece. We don't have it. So once again, there's a couple different ways of doing this one. Let's just go with the easiest. So instead, I'm going to use the similar triangles thing. What's this entire length? 17. Does everybody see that? So now I can use, oh, no, I still need this piece right here. So there's no way of getting out of that. So we know the full amount is 25. We know this piece is x. So what would this piece be?
25 minus x.
Good, 25 minus x. Okay, guys, so here's why it's 25 minus x. If we know the full amount of something, and we know another piece of that, if we want to find this piece right here from E to B, we would take the full amount, 25, and subtract off that amount. True?
True.
So I'm going to say that again. You all should be looking, because if you're working on the worksheet, you're not going to know how to do this one. So I need to see you looking at me. Eyes. I need the whites of your eyes looking at this one. Okay? We know that this full length is 25. Yes or no?
Right.
Okay. We know this little piece is x. So if we take the full amount and subtract off that amount, which is x, We would know that piece, right?
Right.
Okay, and now we can set up the ratio of corresponding sides. So I'm just going to go like this. Since these lines are parallel, I'm going to go 4 over 13. So 4 over 13 is equal to 25 minus x over x. There was another way you could have done this one. You could have done 4 over 17. 4 over 17 is equal to 25 minus x over what? Which one do you want to use? Okay, that's fine with me. Now, one of you should try solving that one, and one try solving this one and see if we get the same answer, because we better. So we cross multiply. Multiply both sides by 25. Divides out over here. Multiply both sides by 17. It divides out over here. Somebody help me out. 25 times 4. 25 times 4. 100 is equal to 25 minus x, and then we have to multiply in 17. So 17 times 25. 425 minus 17x, right? 17 times negative x. So now we have to subtract both sides by minus 425 from both sides. So we would get negative 375 is equal to negative 17x. Then what would we do? Divide both sides by negative 17, and we get x is equal to
22.
Oh, it's not set. Oh.
Oh, mine. You know.
Yeah,
19. Yeah, you guys screwed me up. I listened to you.
Okay, this is where we went wrong. 100 minus 425, guys, is negative 325. Right?
Right.
yes.
That's where. So negative 325 divided by negative 17. Okay, 19.117. Did anyone take the liberty of doing this one?
I did.
Oh, awesome. Did you get the same answer?
Yes.
Woo! Woo! That deserves a cheer. Okay, so you did this one and you did your math correctly and you got the same thing. Pretty cool. Did everybody see the 2 ways you could set this up?
Yes.
Okay, awesome. Finish the worksheet. Well, these problems, 19 through 16, actually. And then I'm going to bring you back to me. Well, yeah, we'll see. Go. No. Next
Is it
video.
80 or